Hello, Honors Algebra 2 Trig. This video is on 9.1 Day 4, Parabolas. And the first thing you need to know is that a parabola is the set of all points equidistant from one point, the focus, and a line, which we call the directrix. Down here we have an image of a parabola, and what would happen is that all of these points would have the exact same distance from this line, the directrix, and this point, the focus. Now I drew this by hand, so it's going to have some flaws to it, but it's pretty close. And you look at this point right here, its distance to the directrix should be the same as its distance to the focus. And say we take this point out here, its distance to the directrix should also be the same as its distance to the focus. I mean, this one looks like it's a little off on that side. It should be a little further down on that point, but that's a key idea. There are several equations we have for the parabola. I mean, there's a lot of them that you already know. We've seen this here as standard form. We've seen this here before. This is vertex form. We've seen this here before. This is intercept form. And then we're going to have this new form down here that's going to focus on talking about the focus and the directrix. And this form is the one out of the four that's new. You're going to notice in this column here, we have very similar equations. These equations are standard vertex intercept form, all for y squared. So the big difference is that we have, for example, here, y is being squared, while over here you had x being squared. They're similar, but what happens is that in the ones we've done before, they've all been functions. So they've all been either upward opening or downward opening parabolas. And the big difference here is that this a is a negative and this a is a positive. And with these ones over here where the y is squared, the y being squared makes the parabola open to the side. So it either opens to the left or it opens to the right. In this situation, the a would be negative. In this situation, the a would be positive. Now the new form that we have, which is this form, in this form, the 4p multiplies by the part that is not being squared. You should notice that it's very similar to vertex form in terms of it's set up to be around the vertex. But the p is the distance from the focus. Sorry, it should be the distance from the vertex to the focus. Now, we're going to find the focus. We're also going to find the vertex, the directrix, the x-intercepts, the y-intercepts, the axis of symmetry, and then we're going to sketch a graph of this one. We're going to use whatever form's helpful to us at the moment. And in this current form, I'm looking at it, I'm seeing it would be really easy to find x-intercepts and y-intercepts. We're going to find our x-intercept happens when y is 0. So the x-intercept happens when y is 0. Well, we can figure out what happens when y is 0. We can just substitute it in for y. So you get 0 plus 0 minus 6, which is negative 6, happens when y is 0. There's only one x-intercept in this situation. It's going to be a sideways facing parabola. Then we have the y-intercepts. The y-intercepts happen when x is 0. So we can make the x 0. And we can go ahead and we can solve this. And seeing that all these numbers are even, we can divide by 2 on both sides to get 0 equals negative y squared plus 4y minus 3. And actually, this one looks like it might factor nicely. I'm going to multiply by -1 on both sides to get y squared minus 4y plus 3 to give us y minus 3, y minus 1. And if it didn't factor very nicely, we could have just done quadratic formula here. So we have 2 points, a y-intercept at 0, 3, and a y-intercept at 0, 1. Now this specific form isn't the easiest form to find the vertex, the focus, the axis of symmetry. It's doable here. It would be, we already have these parts, but in order to find the vertex, I'm going to change it into vertex form. In order to do that, we need to be able to complete the square. I don't know what just happened there. There we go. We're going to carry this function down here. We're going to get it into vertex form. We're going to add the 6 over. We're going to factor out the 2 as the leading coefficient here, -2 I should say. Y squared minus 4y. We need a new number there in order to complete the square. That number is going to be plus 4 because it's b divided by 2 squared. So this is really subtracting 8 over here because -2 times that 4, which means we also need to subtract 8 over here. So we have x minus 2 equals -2 y minus 2 squared. We're here in vertex form, and that's going to tell us that our vertex is 2, 2. Now the focus and the directrix come from the vertex, but we need to know our p-value. So we need to get into our new 4p form. And in order to do that, all we have to do is divide by this -2. So you have -1/2 x minus 2 equals y minus 2 squared. So in this case, -1/2 is 4p. So when you divide by 4 on both sides, you have -1/8 is p. So the p value is -1/8. Now that means that we're going to be shifting left and right 1/8 to be able to find the focus and the directrix. First of all, I want to remember what direction this is facing. It says we have a vertex at 2, 2. We have a x-intercept at -6, 0. We have y-intercepts at 0, 3 and 0, 1. And actually, I'm seeing this parabola start to form, and I know we have an axis of symmetry. Oh, my pen's not writing. There we go. We have the axis of symmetry. At y equals 2. So we see we have this axis of symmetry here. We could have put an additional point at -6, 4 because it's symmetric and we reflect it over. I mean, we have enough here to go ahead and graph. And so we could look at this graph. Well, we want to use our P to find our focus. The focus is going to be inside the parabola. It's going to be right here, and it's going to be inward 1/8. So our focus is going to be at 2 minus 1/8, 2, because it has the same y value and it's been shifted to the left, so changed of an x value by 1/8. So that's 15/8. 2 is the focus. And the directrix is just out here. And it's at x equals 17/8. So that would be a full graph of what we have. We're going to write the equation of the parabola with this focus and this directrix. So I'm going to sketch that to kind of see what it's talking about first. We have y equals 8 up here. That's our directrix. We have a focus all the way down here at 5, -4. 1, 2, 3, 4, 5, -4. So that means we're going to have a vertex somewhere halfway in between. So this here being our 5, -4, we're going to have something right about here that's our vertex. And that has the same x value. And its y value is the average of these two. So 8 plus -4 is 4, divided by 2 is 2. That means it's 6 away this way and 6 away this way. So our current equation is, we're going to go 4p. And because this looks like it's going to be opening down, we're going to have the x being squared. So this is y minus k equals x minus h squared. And in this situation, we know our vertex is at 5, 2, so we have y minus 2 equals x minus 5 squared. The p is the distance from the focus, the vertex to the focus, and it looks like it goes down 6 to get there. So our p is -6. So we have -24 y minus 2 equals x minus 5 squared. And since this is going downwards, it makes sense that this is negative. It will also happen that way if it's opening up to the left, opening in the negative direction. So this is our equation, or one of our types of equation. It didn't give you the specific form, so this is a perfectly manageable type. That concludes the lesson on parabolas.